I'd like to invite O.Tokhiyan, a research colleague from the same institute, who will talk about usage of precision instruments. Thank you very much. I will share with you my presentation on cloud computing and spatial data processing for the integrated geographically distributed information system of Earth remote sensing, IGDIS ERS. The first part of my presentation will be devoted to the first part of IGDIS, to be commissioned this year, and then I will talk about applied tasks where remote sensing data can be used. Then I will share with you our proposals on how to develop things further in this field. The purpose of IGDIS ERS is to integrate ERS information resources into a unified geoinformation space to provide it to end users. The primary tasks addressed by the system is to plan the usage of orbital constellation of Russian satellites, reception and processing of data from both domestic and foreign satellites, systematization of storage of data in one single catalog, and provision of access to this data through various web portals and web services. Functions include the subsystem of planning and management, the subdivision of reception and recording and processing of data, subsystem of storage, and data exchange. The unity of all these systems provides for a full cycle of products of remote sensing data. The main areas of creating IGDIS ERS are to equip all major centers in all regional geographic zones, and these receiving stations are provided with units that can receive data from both domestic and foreign satellites.
Also, we're handling a task of optimization and composition of receiving stations based on the characteristics of the information flows and specs of the satellites. We're establishing a single distributed data bank. We're improving the linguistic support for the remote sensing data. We introduce new information technologies of information delivery to end users, and we're also handling a task of integrating the system with other information systems of federal, departmental, and regional levels. I also would like to make a special note that IGDIS is established within the federal program. It is our institute who is developing the system, and the activities under this program foresee, first of all, modernization of reception and processing facilities. But at the moment we're talking of, first of all, the operational monitoring of Earth from Moscow, also Gidromet centers, and this year we established a center on the Roscosmos in the town of Zheleznogorsk. As a second stage, until 2015, we have plans to do the work on equipping these centers in the Arctic zone. All the facilities which are deployed under IGDIS ensure the work with Resource P, Canopus V, Meteor series satellites, which are on the orbit at the moment, and after launching of Obzor O, Observer V, Canopus VEK. These facilities will work with them, will be compatible with them as well. The overall structure of IGDIS can be visualized on this slide. Here you can see the reception centers of Roscosmos and Gidromet centers and other agency centers. And you can see the networking between them. The networking will be ensured both by the land-based communication lines and translational relay systems via satellites. Our institute has done some research, and the results demonstrate that the overall capacities of orbital constellation of Russian satellites by the year 2025 will increase the load of processing on our reception centers by tenfold, including IGDIS system. This diagram, using the example of resource P series satellites, show that the upper green curve shows that at the moment the reception facilities can receive and do primary processing for only 30%, or in other words, 1/3 of data that the satellite is going to capture by 2015. We can receive up to 84%, and only by the year 2025 we'll be able to receive and process, to do primary processing of the whole volume of data received from this series of spacecraft. At the moment, according to our assessment, the high-level processing will be available only for 25% of data received from this spacecraft, and only to maintain that level, we'll need to launch. We'll need to make sure that by the next launch we increase the number of processing stations and workspaces by the factor of 8 by 2025, by the factor of 29. This extensive approach under these conditions, of course, is unacceptable. That is why we suggest to apply new technologies of deployment of processes of all IGDIS systems. And on the right diagram you can see about the same type of situation, but not in percentages, but in rather gigabits per day. Here I'd like to mention that the main means of dissemination of IGDIS data would be geoportals, which are deployed in the centers in hubs of single database, and some of them work in the network which was established under IGDIS. Others are available through web instruments. The central data bank, which is managed by the Operational Monitoring of Earth, has a Roscosmos portal, and at the moment the most popular services are WMS services, which provide access to the images, transformed images received from Meteor M, Canopus V, and very soon we'll upload also resource P images. The data available through that portal have the accuracy of about a scale of 1 to 1000. In other words, it is a 50-meter resolution, and if the customers place a special order to prepare data with a higher level of accuracy, these data could also, with certain restricted access, of course, be made available through Roscosmos portal. And these IMS services use information monitoring system for the forest status, hydromet system, information system about the world ocean of ICMO, Center of Aerospace Services, and other. The areas of application of remote sensing data are numerous. That would be urban development, tourism, construction. We can look at them in greater detail. Like, for instance, in the field of agriculture, it is well known that agriculture is one of the most painful industries in our country, and the development of this industry is impossible without application of new modern approaches, including remote sensing data. Also, the tasks listed on this slide in the field of petrochemical or oil and gas industry. Again, the further development of these industries are impossible without remote sensing data. And remote sensing data are also very on high demand when doing the environmental monitoring. And the main advantages when using space information is timeliness, high vastness, and lower costs compared to field analysis. To enumerate these tasks in the interests of different sectors, we need not only to provide preliminarily processed data, but also updated information products of high level of processing. In this way, we need to make sure that under IGDIS we develop each stage of the production of our information products and expand capacities of our reception of data from the satellites, expand our capacities on processing the data, and to develop further the existing infrastructure of product dissemination through web services and geoportals, which in fact are also web applications. Only then can we make sure to provide a broad nomenclature of a broad range of different products. And for that, to achieve this goal, we suggest the following roadmap. Step number 1, in the reception centers, we need to create cloud computing data processing centers. We need to place manufacturing processes in this cloud infrastructure, create conditions for placement in cloud infrastructure, technologies for creation of different types of ERS products, and as a conclusion, we need to finally provide access to through special interfaces. This slide, those of you who are interested in this topic will notice the classical architecture of a cloud infrastructure, when physical machines and servers, computers and storage facilities are united through hypervisor into a virtual space, which can be flexibly managed. In other words, there is a way to do a flexible scaling up or scaling down and effectively redistribute the computing resources and operationally place different complexes and technologies, software within this cloud. At the same time, of course, we have plans to take under advisement the specifics of the remote sensing data. Naturally, it relates to the productivity of the network in this cloud and the methods of data storage, both on hard disks and on tape disks, and to use also the data storage facilities of other type, which in general, all these approaches can help us reduce the time for product generation. It will increase the timeliness of product delivery, reduce the costs for the infrastructure maintenance, and reduce the overall costs and prices of the products themselves. This slide shows how we are going to place the existing technological processes within such centers of data processing centers, which will perform the tasks of data storage, processing, and delivery of data through web portals or services. As I told you before, we'll be able to flexibly redistribute resources and effectively scale them up or scale them down, depending on the requirements on processing, the existing load on portals and geoservices, and with the changing volumes of incoming data. At the moment, we are trying to automate the existing processes, make them fully automatic, and this task is being handled at the moment. The task of transformation of images, creating seamless mosaics, spectral vegetation indices, and maps of different sort. We have pre-selected a number of types of maps here, and we're trying to use them to test run our system. At the same time, as we can see in data processing centers, the processing operations will be customized for different types of products, and everything will be done automatically, and the products will become available as soon as possible for the end users. Second approach to product generation is when the products can be generated upon the request from end users that will receive from geoportals. When they will select the type of product, they will mention or specify the time and resolution parameters, and they will specify what data they would like to use to generate these products and other parameters. I can also tell you that now in Russia, in this respect, a lot of work is being done in the direction of establishing or developing technologies of formation of ERS, product creation, and that includes Russian Register Organization and REN organization. And the application of this ERS products is made more difficult because of the lack of single access and the lack of computing power and insufficient input data. And unfortunately, we think that the placement of such technologies like the software and SOD, which receive data directly from satellites, would be a right approach to go about this. Here we need to establish enabling environment to make sure that this system would be joined by these technologies, and as we can see it, we need to specify requirements for the unified applied interface that such software must own, and then we'll have independence from the platform and independence from the development means. Here you can see in that case that the requests from end users that coming from geoportals and services will be broadcast to a particular software, and the generated products will use the input data of remote sensing, will also be placed within the data storage and through the special mechanisms of restricted access, they will be provided to the customers. Different forms of interaction are possible with the developers of such complexes, including the organizational billing system if it is a commercial organization. A few models, as we can see them, a few options of using the DPCCC, that will be software as a service, when in fact the end user can enter a geoportal and through a web browser gets access to the data. Second model is the platform as a service. This is a service for providers of technologies. They get operational system, basic software, and they can place their software there. And the third model is infrastructure as a service, when for organizers or organizations who supply technology need to install specialized operational systems to do that. This slide, again going back to the original scheme, the access for customers and users of remote sensing data, and same processes of data dissemination through GUI tools, web services, through other services, standard protocols will be available through IGDIS remote sensing data. Now, eventually, we see that we'll acquire such a beautiful picture. One, there will be high demand both for technologies of different organizations, technologies of generating information products. One will be able to successfully handle the tasks of processing bigger volumes of data received from satellites, and eventually provide all the interested customers with the products they need. Thank you for your attention. Thank you. It was a very interesting presentation. Would there be questions for the speaker? You had a slide with the data reception centers. Can you do they receive data in real time?
Этот?
This slide? I see no. Yes, yes. I'm sorry, can you repeat your question? You call this reception and the processing, data reception processing center. Do they receive data in real time? For the satellites which do the broadcasting, I mean those satellites that you enumerated, yes, of course, real-time reception. No. Everything depends on the actual specs of those satellites, but then what satellites can deliver it in real time? Well, I'm not really a big expert in this. And the representative of NCMZ tells me that resource P and resource DK can provide data in real time. So technically, there is a possibility to do the same for Canopus V. When are you going to put it into practice then? I'm advised that Rosgidromet satellites also have this real-time opportunity. Okay, thank you. More questions? I would like to ask you a question. I didn't really understand when you were saying about the capacities of the system, that when it is scaled up, it will do 100% of primary processing and some portion of secondary processing. Then, in terminology-wise, what is primary processing? It's a bit processing of raster picture, and what is secondary processing then for you? Aside from primary processing, I'm talking also about the establishment of products 1 and higher, according to the well-known classification. Okay, will there be other questions? Then thank you. Thank you.